In this video, you will learn how to use UltraiQ, your quality assurance software for ultrasound. We will cover the following subjects: the main screen, importing images, supported image formats, administration, adding a hospital, administration, adding a machine, configuring a remote SQL server, changing the user interface language, preparation, calibrating an image, performing measurements using the Cablon general purpose phantom, performing measurements using third-party phantoms, reporting using IQ Monitor, reporting using Excel. If you would like to know how to connect the packs using the DICOM import tool or how to install the software, please watch the UltraiQ DICOM tools instruction video. This is the main screen of UltraiQ. On this screen you will be performing measurements. On the left, right, and bottom of the main screen, sliding panels will appear when you hover your cursor over one of the red buttons with arrows. The left panel is used for administration and settings. The bottom panel is used for viewing and saving measurement results. And lastly, the right panel is used for importing images. To open a panel, hover the cursor over the red button with the arrow. You can close a panel by moving the cursor out of the panel. You can import images by navigating to the right sliding panel. Next, click on the button with 3 dots to open the File Explorer. Navigate to the folder that contains ultrasound images. This folder may be located on a network accessible storage, a USB memory stick, a hard disk or any other kind of storage medium. If you'd like to retrieve images from packs, please use the DICOM import tool. If you want to know how to do this, please watch the UltraiQ DICOM tools instruction video. UltraiQ supports a variety of image formats. DICOM is the preferred image format, since it contains metadata. Other formats like bitmap, JPEG and TIFF are supported but have a few drawbacks like the absence of metadata, which leads to some manual steps you need to perform. Next to conventional single-frame DICOM files, multi-frame DICOM files otherwise known as single loops are also supported. The best practice when doing loss of elements measurements is using multi-frame single loop DICOM files. You can tell the difference between a single and multi-frame file by the icon in the upper right corner of each thumbnail. Multi-frame images are only used for loss of elements measurements. Navigate to the Location tab, found in the left sliding panel. You can add a hospital using the Add Location button. Please fill out the required field, name, by typing the name of your hospital. All other fields on this screen are optional. When finished filling out the required field, press Save. The location has now been added to the list view. Navigate to the Machine tab, found in the left sliding panel. All machines currently known in the database are shown in the upper list view. Use the text box to filter results in the list view. For example, when you want the list view to only display machines of a certain manufacturer, or only display machines archived under specific location. Before adding a machine, make sure the location of the machine exists in the Location tab. To add a machine, press the Add Machine button. Please fill out the required fields for location, manufacturer, model and serial number. All other fields are optional. In case the manufacturer or model of your equipment is missing in the default list, you can add a new one by selecting New in the selection box. Next, fill out the name of the new manufacturer. The next required field is model. The last required field is serial number. All other fields are optional. When finished, press Save. Your machine has now been added to the list view. To edit a machine, double-click on the machine entry in the list view, or select a machine and press the Edit Machine button above the list. When you're finished editing, click the Save button. The transducer list view works similar to the machine list view. All transducers, which are currently present in the database, are shown in the lower list view. In case your license includes the network module, you can configure a connection to a remote SQL server. Navigate to the Settings tab, found in the left sliding panel. In this screen you can configure a remote SQL server. Please note that once you configure a remote SQL server, the performance of UltraiQ will depend on the speed of your network. You can change the user interface language by navigating to the Settings tab, found in the left sliding panel. Select the User Interface tab. In this screen you may change the user interface language to English, Dutch, French, German, Italian or Spanish. Rebooting UltraiQ is necessary after changing these settings. Before we start measuring, please make sure the administrative details of your machine and transducer are saved in the UltraiQ database using the left sliding panel. To start your first measurement, import an image to the main screen. If you're using a DICOM image, chances are that UltraiQ calibrates the image by itself. If you are using a different image format or UltraiQ fails to calibrate the image by itself, please complete the following steps to calibrate the image manually. When you move your mouse over the image, UltraiQ will show you what to do through tooltips. If, for example, you are asked to set the scale, choose a second ruler point on the bottom of the screen. Next, left-click on ruler point 0 cm and the second ruler point indicated by the tooltip. The scale is now set. The next step is setting the middle of the array. You can do so by clicking the left mouse button after positioning the cursor as close as possible to the transducer lens in the horizontal center of the image. To clarify, we give you a few examples. For a linear transducer, the correct position is shown by the yellow marker. For a convex transducer, the correct position is shown again by the yellow marker. For a phased array transducer, the correct position is shown again by the yellow marker. If you are asked to identify the gray map, please identify the position of the gray map in the image. Make sure that the region of interest covers the entire gray map. The region of interest must exceed the upper and lower gray map boundaries, as long as the background of the gray map is black. You can adjust the width of the region of interest by pressing the Shift key on your keyboard while scrolling with the mouse wheel. You can adjust the length of the region of interest by pressing the Control key on your keyboard while scrolling with the mouse wheel. If your image does not have a gray map, please uncheck the Use Gray Map checkbox. Using the Cablon general-purpose phantom is the easiest and fastest way to perform measurements. All it takes to measure any image is one single mouse click, assuming you are using a DICOM image. Before we start measuring, please make sure the administrative details of your machine and transducer are saved in the UltraiQ database using the left sliding panel. First, import an image of a Cablon general-purpose phantom into the main screen of UltraiQ. If you're using an image format other than DICOM, you may need to calibrate the image manually. If so, please go to Chapter 9, Calibrating Images. After importing an image, select the Cablon general-purpose phantom in the bottom left corner of UltraiQ. To perform the measurements, select Measure VP, HP, GT and PD from the protocol list. The measurement will start instantly. You can check the status of the tests under the image, in the bottom right corner of the screen. When the test is finished, the results will be automatically added to the bottom sliding panel. Your transducer's contrast, resolution, distance accuracy and penetration depth have now been determined. To measure element dropout, navigate to the right sliding panel, and select at least 3 images of a uniform phantom or select one multi-frame image and press the Create Median Image button in the right sliding panel. The advantage of using multi-frame files is that you don't have to save multiple single images when doing the acquisition. Simply position the transducer on the uniform phantom and record us in a loop while slowly moving the transducer over the uniform phantom. UltraiQ will now merge our selected images into a median image. When this task is finished, the median image is automatically displayed in the main screen. Launch the Loss of Elements protocol. In case of a curved array, the transducer lens angle will be automatically detected. In case the automatic detection fails, please uncheck the automatic checkbox and relaunch the protocol. Highlight the upper left and upper right corner of the B-mode image. Lastly, highlight the left or right edge of the B-mode image to complete the measurement. Load an image with only the inner air reverberation pattern showing, such as the image in this example. Noise must be visually present in order to perform a successful measurement. Expand the signal to noise section. Launch the sensitivity air protocol. Next, import a single image of a uniform phantom and launch the sensitivity phantom protocol. Both the in-air image and the phantom image must have the same imaging depth. All measurements are now completed. First of all, select the phantom that was used in the ultrasound image. After selecting the right phantom, select the session named All. A list of protocols will be shown. Abbreviations are as following: GT, gray targets, VP, vertical pins, and HP, horizontal pins. Always start by measuring the gray targets images. You can measure up to 5 images of gray targets. The results will be averaged. Count the amount of gray targets that are visible in the ultrasound images. In this case, 6 gray targets are visible. Thus, we will select the protocol GT6. In case only 3 gray targets are visible, select GT3. In case an automatic measurement fails, or is incorrect, please turn off the automatic mode checkbox, and restart the protocol. Move your cursor over the ultrasound image, and follow the instructions. Next, load the images containing horizontal pins, vertical pins, and room for a penetration depth measurement. Count the amount of vertical pins you'd like to measure and start the match in VP protocol. Count the amount of horizontal pins that you would like to measure. Take note of the layer they are in as well. Layer 1 is the most superficial layer. You can either measure 3 of 5 pins in each layer. Next, launch the penetration depth protocol. Select an area in the image where only background is shown. To measure element dropout, navigate to the right sliding panel, and select at least 3 images of a uniform phantom, or select one multi-frame image, and press the Create Median Image button in the right sliding panel. The advantage of using multi-frame files is that you don't have to save multiple single images when doing the acquisition. Simply position the transducer on the uniform phantom and record us in a loop while slowly moving the transducer over the uniform phantom. UltraiQ will now merge our selected images into a median image. When this task is finished, the median image is automatically displayed in the main screen. Launch the Loss of Elements protocol. In case of a curved array, the transducer lens angle will be automatically detected. In case the automatic detection fails, please uncheck the automatic checkbox and relaunch the protocol. Highlight the upper left and upper right corner of the B-mode image. Lastly, highlight the left or right edge of the B-mode image to complete the measurement. Load an image with only the inner air reverberation pattern showing, such as the image in this example. Noise must be visually present in order to perform a successful measurement. Expand the signal to noise section. Launch the sensitivity air protocol. Next, import a single image of a uniform phantom and launch the sensitivity phantom protocol. Both the in-air image and the phantom image must have the same imaging depth. All measurements are now completed. To save the new measurement results, navigate to the Save tab in the bottom sliding panel. You must select both a machine and a transducer from the equipment lists before results can be saved. Once the results are saved in the database, They may be viewed in IQ Monitor, or exported to an Excel sheet. UltraiQ comes packed with a simple-to-use web application to review all your measurements of all transducers in one overview. To open IQ Monitor, press the IQ Monitor button in UltraiQ. IQ Monitor will now launch and open your default web browser. The start page is the transducer overview. Here you see all your transducers in a list view. You can filter the list view through search boxes above the list view. A traffic light will appear in front of each transducer once the transducer has one or more reports archived. UltraiQ uses baselines to determine whether a transducer meets your requirements. It is required to set an overall baseline. This baseline will apply to all transducers. To set an overall baseline, click on the Edit Overall Baseline button. If this is your first time setting a baseline, you only see the Add New button in the Set Baseline screen. If you have added an overall baseline before, all known baselines are displayed in the list view. Click on Add New. A panel appears where you can set the tolerance values for each type of measurement. You can also set a start date and an end date. This can come in handy when you would like to narrow or widen your baselines later in time. Once you've finished filling out all fields, click on the Save button. Your baseline is now set. Click the Transducer Overview button in the header to navigate back to the Transducer Overview. To test and configure the SQL Server connection, click on the Configure button. These settings should not be touched unless you are experiencing problems with the connection to the SQL database. In this screen you can edit the SQL connection string. Click the Test Connection button to check the current connection string. Click on the Save button when finished. You will be redirected back to the Transducer Overview. If you click on a transducer, you will be taken to the Trend Overview page of that transducer. The Trend Overview is divided into blocks. In the block on the top, you can view the administrative details of the transducer. If you would like to define a custom baseline for this transducer specifically, you may use the Edit Baseline button to do so. In the left block, a list of all measurements performed on the transducer is displayed. In the other blocks, trend graphs of the different types of measurements are displayed. The red line in each trend analysis graph represents the baseline. If one or more measurement goes out of tolerance, the traffic light in the report list view will change to red. Since baselines are time limited, it can happen that your latest measurement exceeds the baseline's time frame. For example, the baseline you set is valid until January 15, 2017, whereas the latest measurement for this transducer was done on July 10. In case this happens, you will be notified by a warning. Simply extend the baseline's time frame, or add a new baseline. Let's zoom in on the Loss of Elements block. You may use the Information button to read a short description of what this measurement says about your transducer. To view the detailed measurement results for loss of elements, press the View Details button. The loss of element results are shown as following. On the top half of the page, the numeric measurement results are visible, telling you the total percentage of dead or weak elements, as well as their coordinates. You may use the check boxes to compare different measurements to each other in the graph on the bottom of the page. This graph displays the array performance for the checked reports. Dips at certain positions indicate weak or dead elements. The horizontal straight lines are the upper and lower limits for detection of weak and dead elements. To navigate back to the Trend Overview, click on the Trend Overview button in the header. The detail page of sensitivity works similarly to the Loss of Elements page. The top half of the page displays numeric results, whereas the bottom half of the page displays the detailed measurement graphs. Again, you may use the checkbox in front of each report to display or hide the report in this graph. The SNI graph displays the noise levels measured in air compared to the signal levels measured on the uniform phantom. In some cases, these lines intersect. When they do, the depth at which the intersection takes place is tracked over time by UltraiQ. If the noise and signal lines do not intersect, then UltraiQ will track the SNR at a certain depth over time. On the Contrast Details page, the results are shown as following. On the top half of the page, the numeric measurement results are visible. Each date shows the corresponding measurement result. On the lower part of the page, the results are plotted in a trend analysis graph. This way you can easily compare results to each other. The detail page of penetration depth works similarly to the contrast page. On the axial and lateral resolution detail page, the results are shown as following. On the top half of the page, the numeric measurement results are visible on the right side. On the left side, a graphical representation of the measured horizontal and vertical pins is displayed. You can click on a pin to check the transducer's resolution at the click position. On the lower part of the page, the results are plotted in a trend analysis graph. This way you can easily compare results to each other. At the time of writing, the trend analysis graphs for distance accuracy are not available yet. To export a report to an Excel sheet, navigate to the Excel Export tab. Here you will find a list of the reports you have saved before. Select a report and press the Excel button to export this report to Excel. Click on the Create New button when this is the first time you're archiving a report for this transducer. If you've archived a report for this transducer before, UltraiQ will propose to use this file again. In this case, the existing document will be updated with the selected report. UltraiQ will now export the measurement results to the selected Excel file. Once UltraiQ is done exporting, open the Excel file to view your measurement results. The report in this example contains 5 measurements of the same transducer. You might get a notification about Excel macro settings. Please enable macros. Disabling macros will limit the document's features. On the first sheet, the administrative details of the machine and transducer are displayed. In all the other sheets, measurement results are displayed in detail. A green box behind the report date means that all measurement results of that report are within tolerance. An orange box behind the report date means one or more measurement results of that report are out of tolerance. In this case, further examination of the results is necessary. Please note that baselines configured in IQ Monitor are incompatible with Excel. In the case of this transducer, the contrast and sensitivity have dropped in the last report. The abbreviations used as sheet names, at the bottom of the screen, correspond to the protocols that you executed before in UltraiQ. The gray target results are shown as following. On the top half of the page, the numeric measurement results are visible. Each date shows the corresponding measurement result. On the lower part of the page, the results are plotted in a trend analysis graph. This way you can easily compare results to each other. You can configure the tolerance value by changing the percentage in orange. Type any percentage and press enter. The penetration depth results look similar to the layout of the gray target's results. Again, the top half of the page displays the numeric results, while the lower half of the page displays the results in a graphical view. You can configure the tolerance value by changing the percentage highlighted in orange. Type any percentage and press enter. The horizontal and vertical pins measurements contain a lot of data, but they are also easy to review. Each sheet is divided in 3 parts. 1 page for the axial resolution, 1 page for the lateral resolution and 1 page for the distance accuracy. You can change the graphical view by selecting the pin number. This way you can, for example, view the results at 4 cm by selecting pin number 4. You can configure the tolerance value by changing the percentage highlighted in orange. Type any percentage and press enter. The same layout applies to the sheets labeled HP. The loss of elements sheet show you the numeric results and graph. The top half page displays the trend analysis of the total percentage of elements that performed below the 3 median average deviation threshold. The lower half of the page displays a graph of the signal intensity from the left to the right of the array. Use the check boxes in front of the report dates to change the view in the graph. You can configure the tolerance by changing the percentage highlighted in orange. Type any percentage and press enter. The sensitivity sheet displays the sensitivity of the transducer in a trend analysis graph, as well as signal and noise levels. Use the checkboxes in front of the measurement dates to change the view in the graph. You can configure the tolerance by changing the percentage highlighted in orange. Type any percentage and press enter. The settings and remarks sheet is used to delete measurements from the report and to review any remarks that were written down in the extra information box in the bottom sliding panel. Take note, macros must be enabled to delete measurements. Next time you perform measurements on this transducer, you can add new measurement results to this existing document. The document will be updated with the new measurement results. The overview page instantly tells you whether the latest measurement is within the tolerance you have set. Thank you for watching this video about UltraiQ. If you have any other questions, please contact your local distributor or email us at info@ultraiq.com.